All right, homework 5.5. We are doing areas and volumes, and the volumes we're doing have known cross sections. So recall before we start into this that to find the area between two curves, if we have a top one and a bottom one, and we want to find the area between A and B, that area is just the integral from A to B of the top one minus the bottom one. So that's our area function. And now what we're saying is, well, what if we know the area at any given x coordinate? Like if we know at this x, we know the area of the cross section, and we know it's a rectangle or something. We know how to find that area. And we know the area at every cross section. Well, what then is the volume of this shape that's sticking up out of the page? And so we've got a new formula. The volume is the integral. I guess I should have said this is area. Volume is the integral from A to B of the area at different x's. So if we know all the areas at different x's, we can find the volume. A bunch of different ways we can do this. Sometimes they will literally tell you what the area is at different x values. Sometimes they will tell you there is a shape that's sticking out, and you need to find that shape, the area of each shape. Sometimes they'll do something a little weird, like they'll say, well, like they're rectangles and the height is 4. And so it's base times height is the area of the rectangle, and you can find it. So let's look at how some of these work. I'll try to do some of the tricky ones here. Number 3 says a solid has its base in the xy plane. So here's the xy plane. And it is bounded by the x-axis, the y-axis, and the function 3 minus x to the 5th, which looks like this. Okay, so there's this function, 3 minus x to the 5th, and it's bounded by the x-axis, the y-axis, and this function. So this is the base of the solid right here. Okay. Well, this is a calculator problem, so you can always graph it if you're not sure what the graph looks like. Cross sections are taken perpendicular to the x-axis. So they're going to be perpendicular to the x-axis, and they are semicircles whose diameters are in the xy plane. So if you take a cross section, that means you slice it perpendicular to the x-axis as shown here. What's sticking out are semicircles. So you've got these semicircles sticking out at different places, something like that. And I don't know if you guys can tell, these are supposed to be sticking out of the page. We want to know what the volume of the solid is. Well, the trick is this is the integral from A to B of the area of each of these semicircles. We just need to find a formula for the area of each semicircle. And the area of a semicircle is pi r squared divided by 2. We just need to find what r is. So the radius of the semicircle is going to be half the distance of whatever this height is, because if we've got a height and this is going to be a semicircle, well, the radius must be right here in the middle. It must look like this. And so the radius is going to be this minus this divided by 2. In this case, it's just this height divided by 2. And so the first thing we need to do is we need to find where this point of intersection with the x-axis is. So here's what we're going to do. We're going to go we're going to put y equals 3 minus x to the 5th. And we're going to graph it. Kind of an ugly graph, but that's what it is. It's kind of what we said it was going to look like here. We need to find this intersection. So I'm going to put y equals 0 in there so I can find that intersection. Second calc intersect, enter, enter, enter. And there's an intersection at x equals, so intersection at x equals 1.2457. I went to more than 3 decimal places just because I felt like it here. It's not my final answer. So we're going to do the integral from 0 to 1.2457 of, now we need this formula. It's pi times r squared divided by 2. So I'm going to put, this is going to be my pi, this is going to be my divided by 2. Now I need my r squared. The question is, what is the r? And r here is half of this height. there's a trick to doing this. You don't have to type in a lot of crazy stuff. If you go to Y variables, you press the variables button. It's right by clear. So the variables button is right here by clear. You go to Y variables function, and Y1, we already stuck it in there. Now it's not this height. That's not the radius. The radius is this height divided by 2. So I'm going to put that. This height divided by 2, that is my radius. So this is pi r squared divided by 2 dx. And there's my integral. It is 3.35. So A. All right, let's do a couple on the back that are a little bit weird. Here we've got this region. This was a free response problem. I'm not going to do A. I think you should be able to do A already. B says the horizontal line y equals -2, here it is, horizontal line y equals -2, splits the region R into 2 parts. Write, but do not evaluate, an integral expression for the area of the part of R that is below this line. So they're talking about this area right here. Well, obviously it's the integral from A to B of the top one minus the bottom one. So it's -2 minus the bottom one is, you can always graph it if you're not sure which one of these is the top one, which one's the bottom one. This is x cubed minus 4x. The question is, what is this A and what is this B? And so we need to find this intersection. So what we're going to do is we're going to put in y equals x cubed minus 4x and -2, because we want to know where those intersect. I'm going to change my window so I can see this a little bit. This window goes from 0 to 2 is where the x values go from, and the y values go from, let's just say, -3 to 2, and we should be able to see it quite nicely now. All right, so there we go. Here's this area we're talking about. That's right here. So we want the intersection, intersection is at, so now this is a free response problem. We do, in fact, on our paper need to write down intersection at x equals 0.539, and we need the other intersection over here, second calc intersect, enter, and to get the other one we need to change our guess. Once we have pressed enter twice, it's asking us for our guess. We're going to put our guess over by this other one so it finds it. The other intersection is at x equals 1.675, 3 decimal places on those. And so my integral is going to be the integral from 0.539 to 1.675 of the top one, which is -2. So -2 minus x cubed minus 4x dx. I'm just typing this straight into my calculator. And I'm going to look back here. You know, this -2 is just y2. So what I'm going to do is I'm going to practice this other way. The integral from 0.539 to 1.675 of, in my y variables, I can just do y2 minus y1 dx. So this integral is 0.811. We go to 3 decimal places to get our points. The last thing we're going to look at is D, because D is a little weird, a little bit different than some of the ones we did in class. The region R models the surface of a small pond. So you can imagine like you're looking down at a pond. Here's like some water, and it goes deep, but we don't know how deep yet. Let's read about it. At all points R, a distance x away from the y-axis. So if you are a distance x away from the y-axis, so all points are, so it's kind of like this line right here, the depth of the water is given by 3 minus x. So wherever you are, how deep the water is underneath is 3 minus x. So you can imagine there's this pond and it's telling you, hey, the further you are, the less deep the water is. You know, it's 3 minus x away. That's how deep the water is. So the question is, what is the area at each spot? Well, it's going to be a rectangle because all of these points here have the same depth. And the area of each rectangle is going to be the depth, the height of the rectangle, which is 3 minus x, times the length of the rectangle, which is the top one minus the bottom one. So sine of pi x minus x cubed minus 4x. That is the height of each rectangle times the depth, which is 3 minus x. So at any height, you've got this sine of pi x minus this. That's the height of the rectangle, and the depth is 3 minus x. So that's our area. So it's the integral from a to b of the area. And in this case, the integral, we don't need to do any intersections because it's given to us. It goes from 0 to 2 of the area is sine pi x minus x cubed minus 4x. That's the height of the rectangle times the depth of the rectangle is 3 minus x. So this is length times width, and this integral will give us our answer. Obviously, we need to do this in a calculator and get our answer out, and it needs to go to 3 decimal places, but I'll let you guys do that. Good luck on the rest of your homework.